same sort of thing. Okay? Meaning, if I have a force and a velocity, both of which can be represented by a vector, I can't add those. Because a force and a velocity are not the same thing. Can't add dissimilar things. Similar also, if I had something, I had this as being, this is 5 meters. And B is 3 inches. I can't directly add those. I would have to change the units. That one I can add pretty easily. I just have to change the inches to meters and meters to inches. And then I can add them. Make sure your units agree. This is something in my other class, 2720, that most of you are in. I talked about a lot. Make sure your units are compatible. Otherwise, you're going to get messed up answers. But the more key thing is you need to add like to like. You can add a position to a position. So I just say this is a distance. Let's say this 5 is, as I said, 5 meters. I can add that distance to some other distance, and that's fine. But I couldn't add, say this is the distance and this V, let's say that's a velocity. I can't add the distance and velocity straight up. I would need to manipulate one or the other of them to be able to add them. Okay? And then things like I said, force and distance, or force and velocity, or force and acceleration, or whatnot. Things like that, you can't add them. Those would be, we'd have to multiply them. That's where you get the dot product and cross product, which I'm going to get into down the way a little bit. To begin with, I just want to sort of go into some examples of adding vectors. Before I do, what would be subtracting? If I wanted to have, instead of u plus v here, what if I wanted u minus v? Graphically, what do I do? Where's that? Just drawing on the board. Say it louder so I can hear you.
It actually go down.
Yeah. So all you do is the one that's minus, so here v is the negative one, you just reverse the direction of it. Okay, so it's just flipped the other way. So I had u plus v. If I want u minus v, I just draw it same magnitude but opposite direction. So this is minus v, and so I don't know what I should call this.
R2.
I'll just make up a letter. I'll call it t. So that equals t. Okay, so u minus v. So basically it works the same way as addition. You just switch the direction back to the negative vector is going. Alright, it's still tip to tail, you switch the direction this guy is going. And all this stuff holds true in three-dimensional space just as well as it does in the two-dimensional thing we've got going here. I find it hard to draw three dimensions somehow. Alright? the board.
Yeah, I'm sorry, I just missed it, right, that part.
This guy,
Yeah,
I just drew it in because that's what we're trying to find. We're just trying to find this distance.
okay,
I'm just gonna show you how we find it.
okay.
That's all. And this is a problem, hoping this is a very basic problem. So I said, I'm gonna break each of these vectors, this one and this one, up into units. So our first stretch here, we were going 10 miles east. So we can write that as, I'm gonna do this for this first time. I'm gonna confine it right into the. See what I'm doing. I'm gonna do it together. Let's do several problems. So I have 10 miles I. wanted to know the direction of R. I wanted to know this angle right here. How would I get that?
Wild red or
Yeah. So it's going to be, I'm hearing people saying the inverse tangent, correct? So if I want to know that, I can say inverse tangent, which we write tangent to -1. So tangent is opposite over adjacent. Opposite in this case is 3.5. Adjacent is 16.06. So put those guys in there. 3.5 miles over the 16.006 miles, and that happens to equal 12.3 degrees. Okay? Does everybody hopefully follow along with this? If I were to give you a homework problem doing a very similar type of thing, there wouldn't be too much trouble. Because that's a potential event in your future. What's that? All right. So now, yes, teacher. All right. Let me ask you this. This is a boat. Boat's going water. Let's say there was a current. Let's say there was a current. Let's say there was a current at, say, 5 miles an hour. This is another one I personally find quite confusing. Lisa here? Yeah. There he is. So when we talk wind, when we talk about the north wind, what direction does the north wind go? Yeah, it goes south. Okay? And so currents, I think, are the same way. But this is what I'm asking you as a Navy guy. So if you say a north current, what does that mean? What direction does the north current go in?
good question. Pumping the air. Hold on.
Anyway, so I always find that confusing. The northerly wind is going south. Anyway, so the upshot here is, let's say we have a current in this direction. So we have some current. I'm going to say call it southwest current, which means heading in northeast direction. So we have a current and it's headed this way. Okay? So it's northeast. So we have a northeast current at 5 miles per hour. That's true for all the water on. Nice consistent current across all the water. So can we, so we've got 5 miles an hour here. Can we just tack that on? All right, we've got 5 miles an hour.
No.
This, we had this. We're going to take this off about a 45-degree angle and call that 5 and have a new result right there? No.
Nope.
Why not?
Different units.
So different units, so this is like, I can just change my units maybe, and then I can do it? So what, generally speaking, why can I not do this? It's not a units thing per se. Before I said like we had maybe 5 meters and 3 inches or something, that's just flat out units. I can convert my units and then I can do it. So this is, like I said, this is 5 MPH. So these are not like things. These guys are distances. That's a distance and that's a distance. This result we calculated out as a distance. That's a velocity. You can't just straight up add distances and velocities. Similarly with accelerations. You couldn't add an acceleration into a velocity. So what we need to do, if we're going to try and solve this problem, which we are, is we need to get that somehow into being a distance. Or conceivably, we could turn these into velocities, but I think it's definitely easier to get that one into a distance. So, how would we do that? What do we need to know? We want to be able to turn our 5 mile an hour velocity in that direction into a distance. What would be our first step?